All right, so we're going to get some more practice with simplifying complex fractions. So in this example, 2 plus 1 over t plus 3 all over 1 over t plus 3 plus 1/4. Okay, so again, I'm going to try to find the LCD of all these little denominators, right? The t plus 3 and 4, right? So the LCD in this case, LCD would be 4 times t plus 3. Okay, all right, let me get rid of my circling there. Now, that's what we're going to multiply the big numerator and the big denominator by, right? 4 times t plus 3. Because our goal is to get rid of all of those little denominators, right? If we multiply this thing by 1, we should have it. Now, like I said, if it helps you to distribute those things through, because you're distributing all of this through to both of those terms. If it helps you to put 4 times t plus 3 in each numerator and cancel the things that apply, great. Sometimes I think that can be a little bit more distracting. So you can multiply it straight through. 2 times 4 times t plus 3 is 8 times t plus 3. Right? I just multiplied the 2 and the 4. We'll distribute later. And then 1/3 times 4 times 2 plus 3 is just going to be 4, right? The t plus 3's cancel. Okay. And then on the bottom, 1 over t plus 3 times 4 times t plus 3 is just 4, right? And then 1/4 times 4 times t plus 3 is just t plus 3. Okay, so I'm going to come down here. I've got 8t plus 8 times 3 is 24, right? Distributing the 8 through there, plus 4, all over t plus 7. Okay, so up top we've got 8t, 24, and 4 is 28. Okay. Over t plus 7. Okay, now I can factor out a 4, right? So then I'd end up with 2t plus 7. Ooh, it looks like we should be able to cancel something there, but we can't, can we? All right, that's okay. We can leave it in factored form. And make sure to say, because we got rid of the t plus 3, right? So t can't be -3, right? So pay attention to the domain restrictions of the original complex fraction. Just to look at this again, if what I just did is confusing or you get lost in the steps, I just want to give you an alternative way to write it out if it helps you. Okay, so when we're multiplying the numerator by 4 times t plus 3 and the denominator times 4 times t plus 3, so when we distribute the 4 times t plus 3 through the numerator, we're going to multiply 2 times 4 times t plus 3, right? And we're going to add to that 4 times t plus 3, which gets multiplied to that numerator, right? Divided by t plus 3. All over t plus 3 gets multiplied by the 4 times t plus 3 on the bottom. Yeah. And the 1/4 also gets multiplied by this. We've got 4 times t plus 3 all over 4. Okay, so in the cases, except for that integer of 2, in all the other cases, something cancels, right? We get to cancel the t plus 3 there, and the 4 down here. Okay, so we end up with 8 times t plus 3 plus 4 divided by 4 plus t plus 3, right? Okay. And then we simplified it from there. But that's the same thing we got initially, right? So all I'm saying is that this step right here of like writing it out, If that's really helpful for you to really see when you're distributing it through to see it multiplied to each numerator, do it. If it's not helpful, um, go ahead and do it the way I did it in the first example, in the first way that I did it. Okay? All right. Just some thoughts. Let's try another. All right, so with this one I have 1 over x minus 3 plus 1 over x plus 3 all over 2 minus 4 over x minus 3. Okay, so if we look at all of those denominators, what is the LCD? X minus 3 times x plus 3, right? Those are all the little denominators that we see. So I'm going to multiply the numerator by x minus 3 times x plus 3, and I'm going to multiply the denominator by x minus 3 times x plus 3. Okay, and in doing that, we got to distribute all of this, right, to both of those terms. You can put it in the numerator and write it out like that if you want. But I know in the first fraction the x minus 3 is going to cancel, and we're going to be left with x plus 3. In the second fraction, x plus 3 is going to cancel, and we're going to be left with x minus 3. Okay, that's the numerator. And in the denominator, I have to multiply 2 by all that stuff in green, x minus 3 times x plus 3. And then in the second fraction, I'm subtracting 4 times x plus 3, right? Because the x minus 3's cancel. Okay, so in the numerator, I'm going to have 2x, 3 minus 3 is 0. And in the denominator, I'm going to have 2 times x squared minus 9, right? It's a difference of squares there, x minus 3 times x plus 3, minus 4x minus 12, right? When I distribute the 12 through. Okay, so now I'm going to have 2x over 2x squared minus 18 minus 4x minus 12. All right, still cleaning up that denominator here. So 2x squared minus 4x in the denominator. Negative 18 minus 12 is minus 30. Okay, so the only thing that I see to do right off the bat there would be to factor a 2 out of the denominator. So I have 2 times the quantity x squared minus 2x minus 15. So that cancels. We could also factor that, but I don't think it won't help us simplify it any further, right? So x minus 5 times x plus 3, that would do it, right? But that's fully factored, the fully factored form. It's always good to factor when you can. In our final result, we have x plus 3 in the denominator, but in our original expression, x minus 3 was also a denominator, so we have to say x can't be 3, right? Because that's what makes x minus 3 0. Okay, wonderful. Let's do one more. Okay, so we have y plus 4 divided by y squared minus 4 plus 1. All over 3 over y plus 2 minus 2 over y minus 2. Okay, so the first thing I'm going to do is factor that little denominator. Y squared minus 4 is really y plus 2 times y minus 2, right? Okay, it's a difference of squares there. All right, so I want all of the denominators fully factored so I can determine what the LCD of all these little denominators happens to be, right? So in the big denominator, I've got 2 little denominators, right? I've got y plus 2 times y minus 2, right? Y plus 2 times y minus 2. And that's the only denominator I have in the numerator as well. Okay, so I'm going to multiply the numerator and denominator by that LCD. Y plus 2 times y minus 2. Right? Y plus 2 times y minus 2. Numerator and denominator. Okay, so here's what's going to happen. Upstairs here, we've got to distribute that here and here. So in the first fraction, y plus 2 times y minus 2 is the denominator, right? So it cancels out, so I'm just left with y plus 4. And then with the 1, I have to multiply 1 times that whole LCD of y plus 2 times y minus 2. Okay. Now down here, I got to distribute this over as well, right? Okay, so 3 over y plus 2 times that LCD. So the y plus 2's will cancel. We'll be left with 3 times y minus 2. Minus 2, now I've got 2 over y minus 2. So the y minus 2's cancel, and I'm left with y plus 2 in the numerator. So 2 times y plus 2. Okay, so from there, we're going to distribute. So I have y plus 4, and then plus y squared minus 4, right? Y plus 2 times y minus 2 is the difference of squares. And then in the denominator, distribute the 3 through. So I have 3y minus 6 minus 2y minus 4. Okay, so I have y squared plus y in the numerator, right? The 4's go away. And in the denominator, 3y minus 2y is y. Negative 6 minus 4 is minus 10. Okay, so the only other thing I could do is factor a y out of the numerator, right? So I had y times y plus 1 over y minus 10, but it doesn't help, right? Okay, so the only thing I would question, y can't be 10 in our final result, but in our original expression, we would have said that y couldn't be plus or minus 2, right? That would give a 0 in the denominator. Okay.